Welcome back, guys. Today I'm going to work on a new sensor, that is AIS328DQTR. To gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on this for this sensor, that is AIS328DQTR. So let's see what we got here for this particular sensor, and it's a high performance ultra low power 3-axis accelerometer. As you can see, these plus minus 2, 4 and 8G are the dynamically selectable full scale range of this sensor accelerometer. Also good range of extension for the temperature, embedded self test, 16-bit output data and ROHS compliant. This is the address. As you can see, you can purchase this sensor from here. Now for interfacing, I require an Arduino Nano, and for that a code. So go to the source tab, and here's the code sample as for AIS328DQTR, and this is the code you can download as a zip file. You can also have the code, Arduino code, from GitHub repository, that is Control Everything Community. Now what we require is some hardware and some products so that we can make connections and let it work. First of all, we require our sensor, that is accelerometer AIS328DQTR. Now to make a further connection, we require an Arduino Nano. So to make a connection among the sensor and the Arduino Nano, we need an I2C shield, which you are able to see on my screen, and it's also available on the website controleverything.com. It makes the connection among other I2C devices a lot easier. So gently place over the Arduino Nano over the I2C shield and make the connection. Now we want a connecting cable, which you are able to see on my screen also. Now make this connection among the sensor and the cable, and while making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly we have to follow this rule for I2C shield. So as we done with this connection, finally we had our last connection is to power up the Arduino Nano, and here comes a mini USB cable. So gently place it over the power jack and light it up. Hence we are done with the connections we require for this video tutorial. Let's have a look over the Arduino code so that we can interface and have a working video for this sensor. Well, for the interfacing part, we need an Arduino code, and to get the Arduino code, we have first of all to log into github.com, and here search for the repository Control Everything Community. Now this is the community of controleverything.com officially, and here we have to search for the sensor, that is AIS328DQTR, and here we go. This is the Arduino code, but before looking forward to explore the code, let's have a look over the instructions. It says that we have to download and install Arduino software ID on our local machine, and this is the link, Arduino link, which will help us to stepwise install the software. Let's have a look over that. As you can see on my screen, all the relevant information being provided here: Windows or Mac, Linux operating system for which you can have this Arduino software. So now as we are done with the instructions, let's have a look over the Arduino code for better clarification. It's a .in extension file. First of all, in the code we have included wire.h library and defined the address of the sensor, that is 0x18. Now in the void setup function, we have initialized I2C communication as master, initialized serial communication with a baud rate equal to 9600. Coming to the writing section part, we have selected control register 1 having address 0x20 along with the command, that is 50 Hz for the frequency power on mode, XYZ axis enabled, goes for 0x27. Now we have selected control register 4 having address 0x23. Here we have selected continuous update, and the full scale range goes to plus minus 8G. Now the command is 0x30. So we are done with the writing part. Now we want to read the data, and the data is from 0x28 and 40 is the decimal equivalent of that. We have been requesting and reading 6 bytes of acceleration data for X, Y and Z axis, and here comes the conversion part of the data we have just read. It's according to the details, the formulas we are being provided for the datasheet of AIS328DQTR. So at the bottom of our code, we have the output data being displayed on the serial monitor that we are constantly getting and converting, and the data is in acceleration for the X, Y and Z. So this is the code we need to follow, and we will show the working of this code next. Now let's have a look over the working for this Arduino code for the sensor. So copy this entire Arduino code and open up the Arduino, and here we have to paste this entire code as you can see on my screen, and save the code and name it as you can see. Now here we go, we will verify and compile the code, and now as it's done, upload the code. It's done uploading. Now let's open up the serial monitor so that we can have the acceleration data on the X, Y and Z axis. It's coming through as you can see, it's almost stable, and when I try to rotate the sensor, accelerate in the directions, you can see the change in X, Y and Z axis. It's a raw data which you are able to see on my screen. It's constantly being uploaded and being monitored as you can notice. Now as I continuously rotate, the data change is there. So this is how the Arduino code works, the sensor. Now what we require is to see the benefits and the applications for this sensor. The AIS328DQTR is an ultra low power high performance 3-axis linear accelerometer with a digital serial interface SPI standard output. An I2C compatible interface is also available. The device features ultra low power operational modes that allow advanced power saving and smart sleep to wake up functions. The AIS328DQTR has dynamic user selectable full scales of ±2, 4 and 8G, and it's compatible and capable of measuring accelerations with output data rates from 0.5 Hz to 1 kHz. Now the applications are telematics and black boxes, in-dash car navigation, tilt, inclination measurement, intelligent power saving, vibration, monitoring and compensation, and a lot more. This sensor can be purchased from the website controleverything.com, and the code is available on the resource tab, and after that you can download it from this website. You can also have the opportunity to download the code from GitHub repository, and that is Control Everything Community. If you have any queries, you can contact on controleverything.com, and you can post your comments, your queries on community page. Now for articles and blogs which are relevant to this, you can contact me on instructables.com, and also to subscribe more video tutorials like this, you can have a go through look over our YouTube channel. Now I hope you enjoyed this video and I hope you liked it. So thanks a lot for watching.